Welcome to your lesson on transformations. There are three main types of transformations we'll look at. One is called a translation. That's when you take a graph and you shift it left to right or up or down. Another is called a reflection. That's when you flip a graph over the x-axis or the y-axis. And another one's called a dilation. That's when you compress or stretch a graph. Let's talk about the meaning of parent and child. A parent is the original or basic function. For example, this is a basic quadratic. It's called the parent. A child is the transformed function, a function that has been stretched or compressed or moved or translated or reflected. All right, so here the parent has been changed a little bit. It's moved as a result. This is called a child. Here's our parent, the quadratic. Let's say we want to create a child. We take the parent. It says to create the child, we're going to transform it by taking the original and adding 2 to it. So the child would be the original plus 2. Another example, here we take x minus 5. If you remember how to do function notation, whatever appears in here replaces this x here. So this has been replaced with x minus 5, so this is also replaced with x minus 5. So the result is this child where all of that here has been replaced with x minus 5. Next one, the whole function has been made negative. So the original function made negative. Here, just the x values are made negative. So you take the x thing and you replace it with negative x. So that is replaced with negative x. Like this, it's important to note these are very different. This is in parentheses. They will graph two very different things. Here we take the entire function multiplied by 2. So you take the original function times 2. Here we take the x values and multiply them by 4. So again, this part is replaced with 4x. So this is also replaced with 4x. So it will look like this. All right, let's take some notes on the packet that was given to you. Let's do all the different types of transformations. First, f of x plus k. This will be a vertical translation up k units. At any time, you should pause and take notes. I'll be moving quickly. So here's our parent. Here's the child function, original function plus 2. So original function plus 2. That will graph like this. What has happened is the whole thing has moved up 2 units. So the vertex which was there is now there. Try this one. Here's a cubic function. Please tell me where this point ends up and do your best to create the new function and graph it. All right, here's the new function. Original function plus 3. Original function plus 3. The graph will look like this. Everything has shifted up 3 units, so there's where that location of that point is. Next, try this one. Tell me where this point and this point will end up. Great. Next transformation. Original function minus k. This will be a vertical translation down k units. So our parent is here. We have original function minus 1. So original function minus 1. It will look like this. The entire function has shifted down 1 unit. The vertex was here. Now the vertex is down 1 right here. Everything's shifted down 1. Try this one. This is a root or radical function. Tell me where this point and this point will end up when this transformation is done. All right, here's your function. Original function minus 2, original minus 2, means everything will shift down 2 units. So that whole function has moved down 2. This point has moved down 2, and so has this one. Try this one. Tell me where this point and this point will end up when this transformation is performed. Great. Next one, x plus h. Notice the effect is only on x. All right, this will be a horizontal translation, left k units. All right, horizontal because horizontal means side to side, means moving along the x-axis. And again, this is a change only on the x-axis. This should say left h units because this is h. All right, anyway, f of x plus h. So the original function, this x has been replaced with x plus h. So there it is, x plus h squared in parentheses. The graph will look like this. The vertex which was there is now there at -2. Everything has moved over 2 units to the left. That is important to remember for these ones. When you're looking at a change on x, it does the opposite of what you might think. So it doesn't go plus 2 units, it goes minus 2 units. Try this one. We have an exponential graph. Exponential graphs have asymptotes, so mark that on there. Here's an important point. Tell me where that asymptote and that point will end up on here when this is performed. There's the equation. So the x has been replaced with x plus 1. So that x has also been replaced with x plus 1. The graph will look like this. The point that began here is now here because everything shifted left 1 unit. The asymptote remains where it is, because since we're moving side to side, the asymptote remains exactly where it is. Try this one. Tell me where this point and this point will end up when this transformation is performed. All right, here we have x minus h. This should be a horizontal translation, right, and this again should say h, right, h units. All right, so here's their parent, here's this. So that x has been replaced with x minus 3. So there's the x minus 3 replacing that in parentheses. The graph will look like this. It has moved 3 units to the right. Notice the vertex was 0, 0, now it's 3, 0. Everything has shifted to the right 3 units. Again, it's doing the opposite of what you might think. It says minus 3, but we go plus 3 units. This one, this is a rational graph. Rationals have asymptotes. There's one asymptote at y equals 0. There's another asymptote at x equals 0. Where will those asymptotes end up over here when this transformation is performed? All right, so this is the equation. That x has been replaced with x minus 2, so that x has been replaced with x minus 2. So there's your graph. Notice everything has moved over 2 units to the right. Again, it says minus 2 for the x, but we would go plus 2, so 2 units to the right. The asymptote is now here at x equals 2. This one remains where it was. Try this one. Tell me where this point and this point will end up when this transformation is done. All right, next, when you see a negative in front, that's going to be a reflection over the x-axis. Basically, f of x is the same as y, so we're saying take the y values and make them negative. So for example, we have this parabola with all these y values. Now take these y values and make them negative. So if this one here is at 4, it's going to be at negative 4, and this one's at 2, it's going to be at negative 2. So all these y values being flipped down there, it's a reflection over the x-axis. So this is telling us take the whole function, make it negative. So here's the original function. And we're taking the whole thing, making it negative. So everything becomes negative, that and that. That's important to note, both of them. The graph looks like this. It has been flipped over that line, over the x-axis, reflected. That vertex, which was at 0, 2, is now at 0, negative 2. Reflection has occurred. Excellent. This one. Now we have this one for you to try. This is a quartic function. Tell me where this point will end up when you do this reflection here. All right. Here's the reflection performed. The whole function is made negative, so both of those are made negative. There it is. It graphs like this. The point I was asking about is this one, ends up being right there. Next, try this one. Tell me where this point and this point will end up. All right, now we have a negative applied to the x values. So this is also a reflection, but different. The x values are made negative. So look at this parabola. Let's say this x value here is 4. That x value is 4. Well, it's going to be made into a negative 4. And this x value is 2. It will be made into a negative 2. So notice the x values are being sent over to that side. They're being flipped over the y-axis. So this is a reflection over the y-axis. Here's your original. Now we're going to make the x negative. So that x and that x are being replaced with the negative x. So this will become a negative x. So only this changed right here. The graph will look like this. Notice that vertex was at 2, 0. Now it is at negative 2, 0. So everything has been flipped over this line of symmetry right here to that side, a reflection over the y-axis. All right, here we have one for you to try. Here's another exponential graph. There's a point. There's another key point. There's the asymptote. Tell me where the asymptote and those 2 points will end up once this reflection is done. All right, so hopefully you got this for your equation. So this here, it says the x is being replaced with the negative x, so that x is replaced with negative x. The graph will look like this. The 2 points will be there. The asymptote will remain the same because all we did is flip side to side, so the asymptote is the same. This point remained right where it was because this is the line of symmetry, the y-axis, so that remains there. But this point flipped over the y-axis, ended up there, right here. All right, try this one. Tell me where this point and this point will end up once you've performed this reflection. Now, the 2 tough ones. When you see this Q here, this Q is affecting the x values, and this is going to be a dilation, which means a compression or a stretch. And the stretch factor, the number of times you're going to stretch it, is 1 over Q. So for the x ones, where the number is beside the x, it's really important to remember to take that number here, the Q, and flip it. It's called a reciprocal, because this is really Q over 1. We flip it, make 1 over Q. Really important to remember. All right, so we have the parent function here. Here it says 2x. So that 2x is going to replace this x and this x. So this here is going to be replaced with 2x. So we have 2x squared. That simplifies to this. And then that graph is going to look like this. Now let's take a look at what was happening here. Again, for this one, when we want to see how much it's been stretched or compressed by, we look at this number, and if it's beside the x, we flip it. So this is 2 over 1, so I'm going to make it 1 over 2. So that means our stretch factor is going to be 1/2. That means we take this, and it's horizontal. The effect on the x values is now the x values are half of what they were originally. So for example, we have an x value of 2, and that coordinate is 2, 4 here. So now on the new graph, since we have a 2 here, we know we flip it in half. We know that all the x values we will become half of what they once were. So this x value is 2. Now that x value is going to be 1. So this point, instead of 2, 4, is now at 1, 4. And notice the result is you're like crushing the graph. You're compressing it. You're making it narrower. Let's take another point. There's a point 1, 1 here. That point, the x value will also become half of what it was. The x value here is 1, so now the x value is going to be a half. So there should be a point here. Yeah, there it is, half and 1 on the y. So the y value is still 1, but the x value became half right there. All right. Try this one then. So this is an absolute value function. Here it is. Please perform this. Tell me where this point and this point will end up on the new one. All right, here you go. Here's the transformed function. So x has been replaced with half x, so that goes in here. And now that half x tells us, well, what's the thing in front of the x? It's a half. But when we're thinking about the compression or stretch, we take this number and we flip it. We take the reciprocal. This says 1 over 2, so we're going to flip it and make it 2. So the multiplier is 2. So that means all the x values will become twice as big as they once were. So in the beginning, this x value, for example, was an x value of 2. And now that x value will be doubled because we take that and flip it. We double it. So now that 2 becomes a 4. So notice here it's 4. So the y value is still 2 right here. But the x value used to be 2. Now it's 4. And the same here. This x value is negative 2. Now we double that. It becomes negative 4, which is right here. So the effect is we stretch the graph. We make it wider. We make it wider. So remember, it's kind of like the reverse. That half tells you it can become wider, not narrower, wider. All right, try this one then. We take this function, and there's a 2 there. So what's going to happen? Does it get wider or narrower? And what's that multiplier going to be? Tell me what happens to this point and this point. All right, excellent. Last one. We have the p multiplier. It's in front of the entire function. So since it's in front of the entire function, it's going to be an effect on y values. So this is going to be a vertical compression or stretch by, and this time the factor is p. We don't take that number and flip it like we did for the x compression. We keep it the same for y. So here's our original. Here's a 2 in front of the whole function. So it means the entire function is going to stretch, but it's in front of the whole function. So the whole function is going to stretch up or down because it's affecting the y values. And it's going to make it twice as tall, basically. So now the multiplier is 2. So that's the graph. Let's take a look at one point just to see what's going on. That point is at 1, 1 originally. And now this in front of the whole function means we're changing the y values. So we're going to multiply the y values by 2. So that y value was 1. Now it's going to be 2. So let's take a look. There's a point right there, 1, 2. So notice the x stayed the same, 1, 1. But originally, x value of 1 created a y value of 1. But now an x value of 1 creates a y value of 2. That point has been stretched or pulled up by 1, by multiplied by 2, right? Became from 1 to 2. Another point here is 2, 4. So that point will now be 2, 8 because the y value is made into double. And that one we don't even see on here, but 2, 8 will be somewhere up here. Great, try this one. Another absolute value function. We're performing this transformation. Tell me where this point and this point will end up. Well, here we go. So you write the 2 in front of the whole function. The net result is this multiplies all y values. When it's in front of the function, it multiplies the y values. So here's the graph you'll get. And this point, the y value is 1. Now it becomes a y value of 2. This here, the y value is 2. Now it becomes a y value of 4. So negative 2, 2 is now negative 2, 4. All right, try this one. Where does this point and this point, where do those two end up when you perform this dilation or transformation on this graph?